Welcome to The Mentor. I'm Mark Bouris. Dr Aengus Tran, welcome to The Mentor, mate.
Thank you for having me. Appreciate it.
Vietnamese background. Born here, born in Vietnam.
So I was born in Ho Chi Minh City, Vietnam. 3 brothers and sisters. Both parents are math teachers. So
3 brothers and 3 sisters?
So 3 brothers and 3 of us.
Three
of us.
Okay.
Elder sisters. My brother, which is actually co-founders of the business, Harrison. And then there's me. I'm youngest one in the family. I came to Australia when I was about 16 years old and gone through school and training, and here I am.
So your parents are maths teachers?
That's right. So
both of them?
Yeah, both of them. You know, they knew each other from universities, learning to be math teachers, and they spend their whole life teaching math, high school math to students in Ho Chi Minh City.
Because we're going to talk about artificial intelligence, we're going to talk about machine learning, etc., which is what Harrison.ai does.
Yeah.
But I just want to get my head around the importance of maths. You know, because there's a bit of a fear factor out there about maths, as opposed to it shouldn't be, but there is. You're a GP, by the way, aren't you?
I was doctors by training. Went to medical school in Australia, but never. I didn't specialize as a GP yet.
No.
So I'm a generalist at the moment.
But you have a doctor's degree. It's not a PhD. It's a doctor's degree as a medical doctor.
Yes, there's an MD degree at the University of New South Wales.
Yeah. Great institution, I should say.
I know you went there.
Yeah, great institution. But irrespective of that, you might have done a bit of maths in that course, but it's not a heavy maths degree. Did you do maths all the way along? Were you always sort of interested in mathematical concepts? Or?
Yeah. I mean, growing up in a family of 2 math teachers, I was, exposed to a lot of math training when I was young. In Vietnam, I also went to, selective class that is specifically around more advanced math than most other kid was doing. And my father, of course, he's an innovator. So he was caught on to computer science really early. And there's a big intersection between mathematics and algorithmic design in computer science. So he introduced programming as a subject to high school kids in Vietnam. So growing up, I always been exposed to that. And, we had one of the first early personal computers in the city. Our uncle from France shipped it to us. And, growing up, I remember writing an algorithms with my dad to create a piece of sound that would trigger my dog at the time to do certain command, but it's a frequency that the human couldn't hear. So I would program my dog, if you like, with certain sound signal that get it to do things. So I always had inclination to technology. In medicine, we didn't learn a lot about, math or computer science, but I had an interest on the side. And, it's such a fast advancing field that, by the time you learn it at university, you're probably, a bit dated in terms of what you need to know, right, to build stuff like AI technology. So really, when I was in med school, I caught on to that and went online and did online courses to learn more about AI and machine learning. And it's a really basis to start the business.
Let's just unpack that a little bit. Algorithms as opposed to coding. Let's just put coding aside for a moment.
Yeah.
Algorithm, a lot of people get a bit weird because it's a weird word. But by the way, it's a heavily used word today, but it is a weird word. No one really knows what it means. Let's look at that algorithm you built when you were younger. Can you just go through how you built that?
I mean, the simplest way to think about it is like a system that have some sort of inputs, right? And then there's an output, and you specify what you want it to do. So in the case when I was very young, actually, I was in primary school then, you want to specify that you want a dog to sit when certain sound is played.
So what are the inputs?
Yeah, so the input would be a keystroke that you want to press that would command the software to produce a sound. And the dog would listen to that sound and it would know to sit because you've trained it and you rewarded it for that piece. So that's a very simple version of it, right? And up to a very complex version of it, which is now what we're working on, where the input is a chest X-ray or a CT of the brain. And what you're trying to predict is whether or not the patient has conditions or not, or is it cancers or infections. So the input is the images and the output is the diagnosis or the suggestions of a diagnosis. So it's just various degree of complexity, but at the core of it, there's a piece of work that you want to do and that's highly scalable, right? That's not needed. It's amazing because we have a very advanced algorithm, which is our brain. meaning that through our training, through our decades worth of experience, we can take certain stimulus inputs and produce output based on our own experience. But that's completely unscalable because it takes a long time to grow a human being and to train them, to give them the specialization that they need. So I've always been fascinated by the concept of, getting work done when I was sleeping, distilling the knowledge into these solutions, these algorithms, and then get that to scale the expertise, right, the capabilities beyond what the human can achieve, within their lifetime or not, and with a lot of experience and training.
It's interesting what Harrison.ai does is can do things at scale, and it can actually learn from more outputs, therefore recognize more inputs, and then just keep building. Okay, but we'll get back to that in a second. It's interesting that we as humans are making judgments all day long, making deductions about something all day long based on things that are input through our eyes, taste, smell, feel. They're the inputs coming into us, and they stimulate certain things in our brain.
Yeah.
Then the algorithm in our brain, which is a formula, a recipe that's been built up over either through the evolutionary process, which is genetically there, or alternatively just through our experiences, or maybe what we learned, results in an output or an action. So, I see the light say walk. The algorithm says, Mark,
you walk.
Move your legs, walk, okay? That's what an algorithm is.
Exactly.
But we do this instinctively. It just happens. But what you do is you reduce that to something on a piece of paper. So, not a piece of paper. It's in code.
Piece of code,
but
piece of software.
It could start from a bit of paper though first. I mean, you might just draw it up. How do you start it off? I mean, how do you start off?
Yeah, I mean, obviously where it starts is, is the problem, right? What problem were you looking to solve? So if you take a simple example, which is something I built when I was in medical school, this AI algorithm that helps select human embryos. The input was, these time-lapse videos of embryos. So when couples go and get their IVF treatment, they end up with 20 little embryos that they need to assess.
20 photos.
20 time-lapse videos.
Yeah, right.
Yeah, that's right. And the output is whether or not the embryo are going to create a baby or not, right? Because not all of these embryos is going to succeed when you implant that back to the patient. So you start there, right? What is the problem you're looking to solve? What is the input and what is the output? And then you go and find the latest techniques, right, on what needs to happen in between to create that. One of the advent of the AI technology recently is that instead of hard coding the rules, right, where you would interview an expert, if you like, ask them to write down on papers what make their brain tick, what are the instructions, what are the explicit rules.
Well, they become rules.
Yeah, you create data set, right? Yep. So you create a large database of hundreds and thousands of embryos and the eventual outcome of each of that embryos. And the advance of AI recently is you can have algorithms that learn from that data and distill that into a set of instruction, if you like, that you don't need anyone to write down the rules anymore. In fact, it discover those rules for itself just based on the data. So that's what really made this whole field explode recently, because you had the potential to go beyond what the human expert knows, right, and really discover that insight from the data itself. So that's the modern versions of the algorithms, right, comparing to what I did when I was young, when I was a kid, where I need to specifically specify the frequency of the sound, the keystroke, and what needs to happen there. Whereas in the new world, you just need really good data set that explain the problem and specifying that well.
In terms of getting the data, I think it's probably important that we should explain ethics and ethic approvals and those processes, because a lot of the stuff comes out of hospitals, for example.
Absolutely not, right? And the way that, there's different angles to this. So there's the ethical approval process, because all of these are scientific research, so that require, an ethic board to provide an approval that this meet all the ethical requirements set by, the ethical standards of using this data for scientific research, which is what it really is. And then also the protections of the privacy of the patient. So these data are all anonymized and de-identified.
Yeah, I think you better explain what anonymized and de-identified is, because it's not just They're words, I get that, but you actually strip out of the place where all the information is stored any reference back to the particular individual.
Correct. Yeah. So anonymize is by looking at the data, you couldn't tell who it is. And de-identify mean that, even if you're trying to piece multiple data points together, it's impossible to re-identify the patient. So for example, anonymization may mean you strip out the name, the date of birth, the postcode.
Male or female?
Male or female, the gender.
Depending what it is.
And you really just reduce that down to the minimum data point that you need to create this solution which benefit patients.
So does it get allocated a number?
So you get a random
generic number
generator. So you're really just treating that as an images of an embryo rather than Aengus embryos from 2022. And then there's sophisticated process to make sure that, even with sophisticated re-engineering, you couldn't piece it together. So for example, if you have different time during a year and someone who engaged the service on July, September, and December, you can kind of piece together that even if you don't know the name, you could guess. So there's sophisticated process to shift the date and time such that you couldn't even re-engineer back who it is, even if you try. And there's a lot of good standards set out in Australia on how to do this and doing this well and ethically. And, obviously a big part of what we do is to make sure that we comply with that and at the very cutting edge of protections of both the privacy for the patient and meeting the ethical standard requirement.
So just on that, do they employ blockchain technology to distribute the data so that it's not possible for anyone to even get the data to re-engineer it, as opposed to making it difficult to re-engineer, just redistribute the data?
Yeah, we don't use that blockchain technology at the moment, right? So at the moment is based on, sophisticated encryptions and, this kind of genome data, random data generation process to protect that. And obviously we keep that in a secure way to comply with all the ethical approval.
But it's stored in a data center in a server somewhere.
Yeah, that's right. Yeah, I think blockchain is like a really slow database, right? So, these data sets are quite large. So it's not practical currently to send, a CT scan into the blockchain. But, I think also the key is that, when you use this data set, you need to be highly accessible in one place. So it's just not a good use of that technology currently, but I'm sure that field is moving fast. Maybe things change in the future.
Yeah, I mean, I guess where they can store NFTs and blockchain. Yeah. So I guess they probably could work something around the images, but I mean, mind you, you're probably processing millions of images in.
Millions of images.
Yeah.
And that's really what's the power behind these advances in medicine, which is you can, rather than having one or two clinicians who take a long time to train, assess an images, you can create this large database and distill insight from that. And then from then, this algorithm will scale those predictions, it will scale those insights. And that's what got me really excited about the field, when I was training to be a doctor, is that the scalability of it is really incredible.
For diagnostic purposes.
Correct.
Yeah. So if I just go back a step, here you are doing some courses online, I guess.
Yeah.
And then you're doing your medical degree. Then what happens? Did you immediately go into this venture, or?
Yeah, that's right. Maybe I can take you back a bit of a story here. And so if you take me back into fourth year medical school, I was, and every year I would go back to Vietnam because my family was still living in Ho Chi Minh City. And every year I would do my medical training. There's the holidays. I would go back and spend a couple of months in hospital in Ho Chi Minh City. Because, I was quite eager to see what the difference is between the medicine I was learning in Australia and on the ground. So if I take you back on that year, I went back and I attend a heart hospital in Ho Chi Minh City. And I was very interested in cardiology, which is the medicine of the heart. So I did a placement there. And, when I first started medicine, I had these visions of medicine being like Dr. House or Grey Anatomy or the good doctors, the show that, everyday Australian would know of. This kind of medical diagnosis and mystery, right? Almost like Sherlock Holmes, right? Detective. So I was there, being all smug about my knowledge of cardiology that I've just studied, trying to diagnose a patient and walk through the emergency room. And one of the doctors there, kind of tapped me on the shoulder and said, "Aengus, you dummy. Like, it's really obvious what this patient have. Like, this is not a mystery. The problem is this patient couldn't afford care. So they was here by the time their complications come in. So people presented with very severe heart failures, right? End stage, because they live really far away. They couldn't afford doctors. So by the time they're here, it's not a mystery, right? You need to be able to look after them in an affordable and scalable way. And that's the moment it hits me when I realized that the world don't need another brilliant Dr. House, right? It's not about doing these things that are brilliant. It's about doing the very simple thing, but doing it really efficiently and at scale. So that completely changed my mindset. The last 2-year medical training for me is very different, where I start thinking about how do I do this differently, and there wasn't a lot of options because the medical career is very fixed. You kind of have your specialist training, and then you become a consultant, and then you start your private practice. It was very fixed.
It's very formulaic.
That's right. It's very, there's a ladder that you
climb. It's an algorithm.
Perhaps. And it wasn't very obvious on what I could do. And so that's why I went and studied about AI, and I was quite fascinated by that technology. And, I realized that is the missing piece that I needed, right? Which is, how do I take what I was learning and the problem I see in the ground, which is a scale problem, not a scientific discovery problem, and marry that together into a solution. And the obvious answer to that is to start a business and build great AI solution, put that in the hands of clinicians and scale the work that they do. So that's how I take the leap from just about to become a cardiologist, hopefully, into starting Harrison.ai.
And then where does your brother come in?
So my brother, at the time, he was working at Ramsay Healthcare, which is a great Australian success story on its own, at head of innovation there. And I was a medical and AI mind. I needed a business mind, someone who partnered with. So I said, hey, Dimitri, which is my brother, Dr Tran, why don't you quit your job at Ramsay and come do this thing with me? And I don't know why he agreed to that, but yeah, he came and joined. So he's actually employee number 2. We hired someone first, and then Dimitri came. We moved into a 2-desk office in the innovation centers at Barangaroo. It's called a Harbour City Lab now, I think. And then we start the business from there. It's just the 2 brothers.
And what's his area of expertise?
Yeah, so Dimitri is bring the medical strategy mind and knowledge of healthcare and hospital, but from a business lens, right? So from the economic of healthcare, the economic of running healthcare businesses, and the strategy component of how we can put the business together and build a solution and take it to market. So that's where he came, brought in some of the early day thinking around the Harrison.ai model.
He's your older brother?
He's my older brother. There's 8 years between us.
8 years, wow. And then, because you're not working as a GP,
yeah,
and he's left Ramsay, so how did you fund it?
So at first, early days, we were just funding it out of our own money. I actually had a startup that I built when I was in medical school, second year, and we had a bit of cash from that. When we finished up in the business, Dimitri, take some money out of his mortgage, and we bought our first computers for Harrison, the first supercomputers that we bought to help kickstart it all. We were going just on our own money for a little while. And then in 2019, we brought in venture capital money. So Blackbird, which is an Australian fund, was a part of our first round. We also have Horizon Ventures, which is a Hong Kong based at the time venture capital fund, and then Skip Capital, which is a family office of Kim and Scott from Malaysian. And so the early days of Harrison was funded by venture capital piece.
You bought your first supercomputer.
Yeah.
You just skimmed over that.
Yeah.
Give me an insight what a supercomputer is.
Yeah, I mean, it's not so different to, your everyday computer that sit on your desk, or even in the studio. You probably have very powerful machines, right? And these are just that, but just on steroid, right? They just have much more compute power. They have much more memories. So really, you just take your MacBook Pro and you times that by 10 or by 100 in a single unit. And that's what a supercomputer is. And the reason why you need that in this line of work is because a lot of computation is required to build and train these algorithms, right? To teach it. And if you have a fast computer, that process is much faster. So when we first started, we bought a lot of consumer parts, right? Just your GPU, your CPU, your cooling fan that you could buy in any computer shop. and put together a box. There's an image of it actually, and used to be on our website of that box. We call it Harrison.ai. I remember Dimitri's face when I sent him a part list. I said, I want to build a supercomputers to do AI research for Harrison. And I said, okay, like, we funded together and take some money from personal money to build it. And I sent him the bill, the invoice, and it's full of gaming parts. So that's like, Republic of Gamers, it was Intel gaming, a cooling fan, because that's the cheapest that you can buy, right? Consumer parts. And those are the ingredients that you need to build these computers and use it for AI development and training.
How did you know how to build a supercomputer or cobble together parts that gamers might be using? How did you know this stuff? I mean, just YouTube? How did you find it out?
YouTube is an amazing place, right? And whatever you want to learn this day, you can learn online. And there's a niche corner of the internet that will have someone who teach you about it. And what is really powerful for me is that I always believe in learning based on a project, right? So there's something that I would like to achieve, which at the time was building an AI to classify human embryos. And then I just go down a rabbit hole on everything that you require to achieve the goal. And I always find that really accelerate the learning rather than, doing a course on computer building, because then there's no objective, there's no goals. But when you see so clearly what you want to achieve, then anything in your place, an obstacle is an opportunity to learn. And just go down a big rabbit hole about computer parts and supercomputing building, and that's how I got into it, right? Which might be strange for doctors to go and build this piece and building AI, but I had a goal in mind I wanted to achieve, and that's what drive me.
I'm going to go to the break. I'm going to come back. I want to actually talk to you about this rabbit hole or the lifestyle that people who start these things off experience, because it can be a bit weird, like up to 2-3 in the morning and then doing stuff, like it's a bit of a weird lifestyle, because I've experienced it in my life, these rabbit holes, because that's a big deal.
Yeah.
And it's quite special in terms of the mindset of what you need to do to achieve, say in your case, what you've achieved. Let's go to the break. We'll come straight back.
Sure.
Okay, we're back. I'm dying to know a bit of an exploration for me about mindset of people like yourself. You've decided you want to build your own supercomputer. You can't afford to buy a proper one, like the
one that university would have.
Yeah. These things are pretty expensive. You know why you want the supercomputer, because you're going to have a lot of computations that need to be made at a fastest possible speed. So you decide you're going to cobble together one. You're a medical qualified doctor, but this is not your area of expertise. You're not a computational scientist. You're not etc. You're not an engineer. You didn't do electrical engineering at uni or something like that, and you decide to learn for yourself. I want to actually understand the mindset of someone like you. How do you manage to learn these things on YouTube and then go off and buy these things without making too many mistakes? Or did you make mistakes? I mean, and what is it when it's really fucking confusing and like, hang on, here's an area I never studied before. Like, I better go and look at that.
Well, I mean, what I keep coming back to is very compelling goals, right? So when I was going through this process at the time, I had a vision in mind that I wanted to build an algorithm that helped couples who's looking to get pregnant select the best possible embryo and get pregnant as soon as possible.
From the 20 or so embryos that they've got as a result of the IVF.
That's right.
Or that one session or that
one. That's one treatment cycle. They have 20.
Yep.
There's a time-lapse videos of each of the 20s. There need to be a piece of software that decide which one is the best one.
Yep.
So that really is the kind of like the North Star for me, right? And then that's how I keep the focus and it's not distracted, because when I was learning about AI online through courses online, I was learning it for that purpose. When I learned how to build computers, because the algorithm was taking too long to run, so I need to build computers to make that process faster.
Your computers were taking too long. Your current computer, not the one you built, the one you bought.
That's right. The laptop was taking too long.
Yeah.
So the solution for that is a bigger computer. And then from there, I think that's how you keep the focus through this learning process and stop you from getting distracted, as if you like, because everything I was working toward was to achieve this singular goal, including starting Harrison, right? So Harrison was a means to accumulate resources and talents, right? Even the building that solution was taking too long because it was limited by my own 24 hours a day.
Totally.
Right? So building Harrison as a business and recruiting these people, and we're growing to 200 people now, is all to achieve that very same thing. So that's how it maybe sounds like a lot of like different skill set and expertise, but I never see those as distraction. I see those as necessary understanding. And I think you mentioned about engineers or medical doctors, and one of my pet peeves is that there's no such thing as doctors. There's people who are medically trained, right? They have a skill set and understanding of medicine. There's no engineer. There's just people who know the engineering process and they can do that. And sometimes when you put some of these pieces together, right? Entrepreneurship, engineering, medicine, that's when you create some of the best stuff. And that's how I think your question was, how do I not getting this sidebar, right? Because if it was not serving this kind of goal, then it is a sidebar and it kind of stop.
Because you don't want to fall into Alice in Wonderland.
Yeah, that's right.
You get completely distracted by what the hell's going on, didn't it?
In the very beginning, it was a very small team. There's a handful of us, so there's not a lot of other engineers. So I was doing a lot by myself early days, but we grow very quickly. So that changed very rapidly. Our whole engineering team is based in Australia, in Sydney actually, and then only recently we start growing to other states. So we haven't really worked with overseas engineers too much. We have a few, but I think the general piece for me is that as if your vision requires some piece of technology or core knowledge, is very important that as leader of that business, you at least have a very detailed working knowledge of what you're looking to build, even if that means you need to bring in people to help. Because I think there's because the innovation come from collisions of different ideas, right? And if you don't fully understand the problem space, the technology, then some of those ideas may not come about. So even though now I do very little programming and coding, I'm still very much close to it, because I do believe that that's where some of the growth in the business will come from, is the understanding of the problem space, which is medicine, and the technology, which is AI.
Did you teach yourself coding languages like Python, etc.? Did you?
Yeah, that's right. Yeah, so I part of the different Alice in Wonderland, right? So Alice in Wonderland, there was a Python couple of weeks where do a big deep dive in that, and then there's a algorithmic design course, there's computer parts, so there's this different piece, but because I was facing some kind of stumble block, right? It's like I couldn't progress because I don't have this skill or I don't have knowledge of it. And then that's kind of how it started early days. But now we get to a stage where the problem is we need more people who knows that even better than I do, right? Yeah. Bring in deep specialists. But I feel like I get at least the broad level understanding on everything and be able to piece that together.
What would you say in your field? Well, it's medical, obviously, but it's also scale solutions. What would you say is the minimum to run Harrison.ai? I mean, like, I'll give a really simple example. If I'm opening up a restaurant, a Japanese restaurant, there's no point in me going hiring a Japanese chef. I better know about Japanese cooking myself, right down to the Japanese knives that they perhaps need to use, where to source the best salmon or whatever it is we're going to put up on our menu. My view is I would need to at least have some experience in that, not just knowledge, some experience as well, in order for me to go hire the Japanese chef, because I don't know who I'm hiring. I don't know what I don't know. So like I could end up with the wrong person. But also, if my business needs to be successful, I need to know at least about what the output's going to be, because I might want to talk about it to my customer, or I might definitely want to talk to my chef about it. And I want to make sure I got the right pricing, etc. What are the minimums for, say, someone that you're in your business?
I think I keep telling the team is that we're in the business of healthcare. So even though we're building cutting edge tech, actually blasts all over our even lanyard or posters is the word that we're here to impact 1 million lives a day.
That's your goal.
That's the goal. And that's patience on the other end, right? So at the minimum, people need to have some appreciations of the healthcare system and the realization that we're here building technology that impact patients' life. And then from there, right, depending on what you're there for, you have different specialties area. So an AI engineer may bring, the AI engineering mind to it. The medical device guys will bring regulations and research mind to it. And the marketing team will bring in their skill set on how to best communicate this to doctors and patients. But everyone is united by that goal of touching 1 million patients' life per day, recurrent, meaning that the recurrent part is important, because in medicine, you touch 1 million life a year, then next year you need to do it all over again. You start in zero at the beginning of every year. But with AI, right, because it's software, it's recurrent. Next, you don't need to do the work, quote unquote, again. And then the other skill set, which I think is really important as well, is this ability to understand how the technology is going to fit into the workflow of a doctor's, because these algorithms is no use if people couldn't use it. And therefore, we have a lot of focus in our team on speaking to doctors and speaking to people who are users of this technology.
Education.
That's right. And then getting them, across that, because usually people come in from all sort of other areas, right? Like, fintech and, property tech. But they bring, like, for example, Python skill set, but they need to know how it's going to be applied. So I think that's at least the minimum.
So where do you go to learn more about artificial intelligence, what is otherwise known as AI?
So I think the best way to learn about AI these days is to do a course online, right? So I would advise that pick a problem, something that excites you, something that pulls you, and then go online and find the latest course on machine learning and AI. And there's really good material this day. My first course was in Udemy, and then I did a course on Coursera, and there's a lot of information there. It's such a fast-moving field that I feel like doing a course at university, especially if you're already working and you're already an engineer or you're thinking become an engineer, that the field might move on too quickly. So what I would suggest is to find online resources and follow from there. But have to have a project, have to have a piece of technology you're looking to build, because there's just too much to learn in AI, and you might get drowned very quickly on the detail. But if you have something that inspire you and excite you as a product, that will motivate you a lot more to learn more about it.
So Harrison.ai today, where are you at with Harrison? Give me a thumbnail sketch of where you're at today, and because I wanted to ask you where your applications.
Yeah.
What are you looking at?
Yeah, so Harrison, we so far raised about 156 million Aussie dollars. That's recently in combination as part of a Series B. And our Harrison model is to build businesses. So Harrison has different ventures in partnership with great healthcare company in Australia like iMed and Sonic Healthcare. So we have an arm of the business called Analyze.ai, which work on AI for radiologists, so medical imaging, your chest X-ray, your CT. And we recently launched another arm called Franklin.ai, which is a ventures in pathology, so in biopsy and microscopic testing. So that's where we are. We have two business and capital raise at Harrison. In terms of the team, so if you combine, all of the team members across Harrison, Annalise, and Franklin, we north of 200 employees across the world. Most of them are here in Australia. There's some of them in Vietnam, Ho Chi Minh City, and overseas as well. We're growing present in the US and Europe. In terms of the product, the Annalise Ventures in the field of medical imaging has two products. One is looking at the chest X-ray, which is X-ray images of the chest here, and CT brain, which is cross-sectional images of the brain, which is done when people have a head trauma or brain tumors or bleeds. Though? It's CT, so CT. It's not MRI.
Can you explain the difference between MRI and CT then?
So with CT, you use radiation to penetrate through the tissues and get images from that. MRI, you use a magnetic field, right? So you put a magnet near the head and then you excite a neuron and that create images. It gives you different view of the brain. MRI tend to be more expensive, harder to do. CT is your bread and butter, right? It's very common. If someone fall and hit their head, they probably end up with a CT brain.
So brain and chest?
Yes. So we have two products. They are like a spell checkers for radiologists. So radiologists would read this scan, and then they can run those scans through the algorithm. The input is the images, the output is over 100 different diagnoses or findings. And just like when you write an email, you have a spell check to make sure there's no silly mistake. The AI is a second pair of eye for the radiologist, make sure they don't miss critical diagnosis. And that applied to the chest X-ray and the CT brain.
So, and if I could just go back to the work that the supercomputers were doing,
Yeah,
is that when the radiologist takes the images and then inputs it into the software, the algorithm actually looks at all the people you've looked at forever.
That's
like
right.
Ever since day
Big
one.
database. Yeah.
Big database. And then off the back of that, it can predict outcomes as a result of or diagnosis, or help the radiologist come up with a reading of the CT scan, yeah?
Correct.
Is that what we're talking about?
Exactly.
And every time the radiologist inputs it, that input stays in the system.
Yeah.
And then that information then somehow gets de-identified, but also that forms part of the population of data that sits in the machine learning.
Yeah. So at the moment, we don't do continuous learning, so the system don't change.
Right.
We have a big database. So for the chest X-ray, for example, we have created a data set of about 750,000 chest X-ray, which is a large database. Each of these X-ray was labeled by doctors. So some radiologists have to go in and say, this chest X-ray have finding A, B, and C. There's infections, there rib fractures, there's enlargement of the heart, for example. And they annotate this data set for millions of labels. It's actually take about 100,000 hours worth of labor for doctors,
of other people's labor
of doctors to create this data set.
Yep.
And then once we have that, we train an algorithm and distill that into what we call an AI model. And that doesn't then need to be retrained, at least not continuously as you described.
Right. You don't continuously update it, so to speak.
Exactly. And for the radiologist, this is game-changing for a couple of reasons. So imagine an everyday Australian who get a chest X-ray as part of their health check, either for visa applications or other reason. At the moment, because of the capacity shortage, it takes 14 years to train a radiologist, and there's annual growth of the chest X-ray volume. And what that means is there's a growing gap between the capacity to read the X-ray and the volume of chest X-ray. So for everyday Australian, what that means is that you face anxious wait. The wait is just getting longer. And during that time, you're kind of anxious. You don't know what's going to happen. Or the doctors is working much faster. So in the past, people used to 5 minutes to read a chest X-ray. Now it's in 20 seconds. So imagine, you work 10 times as fast as you used to do. So that introduced possibility for errors. So the way that the game algorithm will help with this is, number one, it's a spell checker, right? It's a second pair of eye. If you're tired, you're in the middle of the night, you just have a big burrito and you're kind of sleepy, right? The AI will catch any kind of critical mistake, which could be life-changing or life-threatening for the patient. And then the second piece is it doesn't sleep, right? So at night, when there's no radiologist coverage, or in a rural region of Australia where there's no radiologist, instead of waiting for that scan to be sent to other places, potentially days later or weeks later, the AI can read it. And if there's a critical findings, it will inform the doctors right away.
So the critical findings are more likely to be exceptions.
Yeah, or life-threatening. Yeah.
Are they exceptions? And does that get then forwarded onto a radiologist before the diagnosis is made?
Yeah, that's right. So today, if you go to a rural region and get a chest X-ray, you won't get the result until maybe a week or two later, because X-ray need to be sent somewhere else where there is radiologists. They'll read that, and then the result is sent back, right? So if there is a lung cancer, for example, you won't know until weeks later. And as the volume increase, that long lead time will increase further. And I'm sure you would agree with me that, people want to know, right?
Totally. So what does Harrison.ai then do? So Harrison.ai's software will actually read that immediately.
Yeah, because it's software and it can read infinitely scalable. It can read overnight. It will pre-read on this X-ray, and if there's things like cancer or infections or any critical illnesses, it will immediately flag this case as high priority.
Yeah.
Meaning that you skip the queue, right? You go to the front of the queue, get the diagnosis right away, and get treated. And for the majority of patients, these scans will be normal, which means that they're probably all right to wait a few weeks without any real consequences there. So when there's lower supply than there is demand, you want to prioritize that supply to the most critical illness, right? Because then you increase the effective capacity of the healthcare system.
In terms of CT scans of the brain,
Yeah.
what are you looking for there?
So the CT scan piece is something that we just spent a year and a half building. Very proud of the team at Annalise to achieve that. But it looked at 130 different things. So that including stroke, brain bleeds, brain scalp fractures, brain tumors, increased pressure in the brain. So because the brain is a sensitive thing, anything to do with the brain is critical.
Yep.
So it does the same thing. It look at the CT scan immediately the moment that you take the pictures. I always like say radiology is like Instagram. Accept the images. It's much more expensive to acquire, and there's consequences with the radiation. But it looks at that and it tags it with 130 different yes/no answer. Really, is there stroke? Is there fracture? Is there bleeds? And then that present to the treating doctors at the emergency room or the radiologist. And if there's a critical finding like a stroke, like a bleed, you get to the top of the line right away and get the care you need. And what that means is, Australians are not waiting in the ED room for their result only to know like 4 hours later that there was a critical finding that should have been attended to.
Yeah, let's say I had a stroke. How quickly does the emergency doctor know this?
So in the past, right, they used to wait, an hour or so, right, for a radiologist to get to the case. Yeah. And without that, they just couldn't know what's going on. With Annalise, the algorithm runs within minutes, right? So within a few minutes of you leaving the scanning table, probably even before you put the clothes back on, the result is already available for the clinician, and they can immediately decide if this is an urgent case and need attention to or not. And certainly also overnight, when people are fatigued, they're tired, they can make mistakes. These are human. The neural network here is the human brain, right? They can make mistake. And when the mistake can be devastating sometimes. So I have a story of a clinicians who have a CT brain of a patient who come in. They decide that it was normal. They send the patient home because the CT scan looked normal. This is a patient who got drunk and fall and hit their head on a pavement. And days later, the patient represented with significant complication of that and eventually passed away. And it's a tragic story, right? To really tell us that getting things right in medicine is life changing for people.
Wow, I mean, I was just thinking of regional areas in particular. Like there are a lot of accidents in these places, and they don't have access to radiologists.
That's right.
Like you do, say, down the road at St. Vincent's or something like that. There'd be one on call 24 hours a day. But I can see the application. How hard has it been to train, I guess, the clinicians? I mean, because you've got to speak a certain language.
Yeah.
You've got to take them through the process,
training them how to use the system.
Yeah. Well, why it's important for a start.
I think in the early days, people like any new technology are quite understandably quite skeptical, right, on what this mean and what we would do to their professions and their day-to-day practice. But now the tool is being used by 1 in every 4 Australian radiologists. So that's a substantial proportion of the professions. And once people see it, they realize that, why wouldn't you use it? I actually hear that all the time because it's like wearing a seatbelt, right? Why wouldn't you put on a seatbelt when you're making such critical decisions for patients? And everyone is aware of their humanity, right? The fact that they can make mistake and the fact that they wouldn't be available all the time. Everyone who used the tool so far, after a couple of weeks, all have a story of a near-miss experience. So a doctor told me the other day that he got back from a shift at the hospital and start the second day of work, if you like, from home, reading this scan at home. And he realized that Annalise has come up and flagged that there is a bleed in the brain that he didn't originally see. And he said that I would have totally missed that, and that would have been a very bad news for this patient subsequently. So in that very moment, he knows that this technology is a safety net, is a partner for him in order to do the work more effectively and safely. So once people realize that, I think the adoptions and the enthusiasm has really grown. And I hear story on the time on how this can be used, like in rural region overnight when there's no coverage. Because at the end of the day, we're in the medical profession because we want to help people and we want to get it right and we want to live a good healthcare, and a lot of people are on board with that.
Angus, do you have a question for me?
I'm quite curious to know. You work on many things in your career. What's next for you?
For me, well, to be honest, there is no what's next for me right now. I'm probably really keen. I'm going to have a few little side ventures. I've always got side ventures. I've got one in gaming, which is and betting on gaming and gaming itself for gamers. I'm talking about. I'm doing that venture with a particular individual. I'm doing lots of little things like, I'm developing my own protein shake for people over 50.
Oh, wow.
Because I think we don't have enough protein or access to enough protein. Plus, we're not going to sit around eating steaks and, chickens and all that sort of stuff. But we do need it. We tend not to eat enough protein, I think. And but my main thing is making sure my financial service businesses just keeps lending money to people. And does that properly. And, like you, we are employing machine learning into our app about what people need to know. Because there's a lot of stuff out there that we keep getting told, but they don't really need to know it. We need to know. Well, then our machines should tell us what it is that we need to know about a particular person trying to borrow money to buy a house or investment portfolio, whatever it happens to be. And, of course, my mentor business. I mean, this is a business I really want to develop more and more and more because I want to build my audiences because And to do that, I need to have interesting people like you come in on the show in a business sense. And I like learning about what you're doing. I love to learn about what people are doing, but I love to be able to parlay what you're doing to my audience so that they can get a sense of all the great stuff that's going on out there. There's so many great initiatives out there. And as you said, your dad was an innovator. You're an innovator. I want to take all those innovators' ideas, maybe even just their dreams, and actually play it to them, to play it to my audience, and hopefully it might just spark something in their mind. Or, I asked you, what's the baseline that you need to have in order to run your business? You're not an engineer, you're not a computer scientist, but you understand engineering to an extent, you understand computer science or coding to an extent. What are the baselines so that someone out there might be also doing a PhD in epilepsy and might be thinking to themselves, I'd like to do a product, but I don't really know how I should go about it because they're an engineering thinker. You know how engineers think. They think a certain way. And that person might be that one person might be listening to this one podcast and get a great idea and come up with a way of building predictive models around using machine learning around detecting when an epilepsy episode is about to occur. And stop people having accidents in cars and because they've had an episode. That's my big objective these days, is especially with the mentor business, this podcast.
To inspire.
To inspire people, but also to empower them.
And
that's a shit word everyone uses all the time, but actually to empower them with a bit of knowledge that someone else has done. And you've done the hard yards. You've done all the trial and error. I mean, you're being a bit modest here. It looks like you just woke up one morning and decided to prepare all this. But this has taken tens of thousands of hours of your thinking and effort to get it to where it is. And it's going to take tens of thousands of your whole team's hours, all of you, to get it really streamlined in 5 or 10 years' time. But it's a big deal. And but most people don't know where to start. Which is why it's important for us to show them how these things start. How does it start? And you funded it yourself. Like your brother borrowed money against his mortgage and you had a bit of money saved for something else you'd done. Everyone who just assumes, mum and dad gave him $1 million. Nah, your parents in Vietnam, your dad's doing his best teaching maths and mum is as well. So that inspires people. That motivates people. So that's my game. That is my game.
Thank you.
And I've really enjoyed this discussion. It might be, hopefully, people listening to it didn't find it too deep and too gritty. But sometimes I like to get in the weeds and sort of dig around a little bit. And I really enjoyed this discussion. Thanks very much.
Oh, thank you. And from my side, just like when I started a business, there was not a lot of example of people that look and sound like me, who was learning medicine and work on innovation. So part of the motivation for me to be here is hopefully inspire a medical doctor somewhere who's maybe part of their training or already practicing, who knows that, in medicine, there's other ways of creating impacts, right? A lot of way of affecting patients' life. And that doesn't require you to put on a stethoscope and show up at the hospital every day. And I still count what I do as practicing medicine, just in a very unique and scalable way. And hopefully that inspires some people as well who listen to this.
I love your objective, 1 million patients a day. And by the way, that's compounding. So that's a lot of people.
Recurrent, right?
Recurrent. That's a lot. Thanks very much.
Thank you. Thank you for having me.